Statistics, Modeling, and Finance. Chapter 3, Measures of Dispersion. Page 5, Sampling Technique. Sampling technique. A random sample is defined as, in statistics, the result of a sample selection process where all the numbers of a population or population stratum have the same probability of being selected. For sampling techniques to work properly, they have to be random samples. Each item in the population needs to have an equal chance of being selected. On a roulette wheel, there are 36 numbers, plus 0 and 00, for a total of 38 possibilities. Each spin results in an equal chance for each choice to come up. A series of spins would generate a list of random numbers. There are 52 cards in a deck. If, after shuffling, you were to draw one card, each one has an equal chance of being drawn. Computers can be utilized to spit out sets of random numbers. Let's get back to our election discussion. If you want to employ sampling techniques to predict election results, you have to figure out how to make sure you draw a random sample. It's not as easy as it seems. You want to make sure your sample represents the thinking of the electorate as a whole. Or, better yet, those who will be voting only about 45%. How would we undertake such an assignment? We could make phone calls at random. Perhaps go to the local phone book and call the 10th person on each page. That seems pretty random. Of course, that would only include persons with landline phones. What about the ones with unlisted numbers, or who screen calls, or will hang up when you say you are taking a poll? Perhaps the majority of the ones who participate in your poll will be disgruntled ones with an axe to grind. They may be happy to give their opinion, but it might not be representative of the population as a whole. What if you stood on the street corner and asked people at random who walked by? That might work. Just make sure you are not standing in front of a political party headquarters. That could produce a biased result. Bias is defined as, in statistics, a systematic error. A statistic is biased if it systematically differs from the population parameter being estimated, such as the average sale price. An example in appraisal valuation modeling would be if the model results in consistently overvalued or undervalued properties. A random sample is not biased, but we have to work hard to get a truly random sample. If we work our street corner and ask questions of people as they pass by, we are not getting to the people who drive to work or take the bus. We miss the people who work at home or are housebound by disabilities. We also will probably meet people of a predominant economic level or group of people who live or work in that area. For example, if you are standing on a corner near a house of worship, when it lets out, your sample may be biased by a strong group of religious beliefs. End of page.